Assalamualaikum warahmatullahi wabarakatuh. Today, my friend Faidatul Fasriza binti Cik Muhammad Asri, Fairuz Fakira binti Wayab, and I, Nurin Farahia binti Muhammad Yusri, will present about G-class star.
Stars, whether they are million or billion years old, all are born in a solar nebula, a cloud of mainly hydrogen gas and dust. There are few factors that can be used to classify the stars. One of the classification is known as the spectral class, which is based on the surface temperature. It used the letter O, B, A, F, G, K and M in order from the hottest to the coldest star. Another way to categorize the star is based on luminosity class or brightness of the star. Class into 9 groups. It ranges from the small, moderately bright white dwarf to the huge, extremely brilliant hypergiant. According to the luminosity class, class G star are in main sequence group. About 7.5% of the main sequence star in the solar neighborhood belongs to the class G star. Class G star are in main sequence, which also known as the young stars. While the cosmos contains billions of stars, the one at the heart of our solar system has a special significance for us here who live on Earth. Our Sun was formed about 4.5 billion years ago in the Milky Way galaxy Orion spur. It was created when the solar nebula, a cloud of mainly hydrogen gas and dust, collapsed. In the midst of this development, materials condensed to form protostars, which then developed into a flaming ball of gas that is our Sun. Our Sun then became the heart of the solar system thanks to its fiery nature, strong gravitational pull, and vast magnetic field.
Next, I will show the example of star in class G. First, we have Beta Carinae Venaticorum. It is a G-type main sequence star in northern constellation of Canis Venatici, which is also known as Cara. It is the second brightest star in the constellation. The distance between the Sun and this star is 27.6 light years, which is 8.5 parsecs. Next, we have Eta Bootis. The binary star Eta Bootis is located in the Bootes constellation. It is roughly 37 light years, which is 11 parsecs away from the Sun. Next is Beta Aquarii. The only stars in the Aquarius constellation is called Beta Aquarii. This star is situated around 540 light years, which is 165 parsecs away from the Sun. Then we have Sun. The star at the center of the solar system is the Sun. The majority of the energy used by life on Earth comes from this source. The Sun's diameter is roughly 109 times greater than Earth and about 1.39 million kilometers away. Approximately 75% of mass of Sun is made up of hydrogen, and the remaining is primarily made up of helium, with lesser amount of heavy elements such as oxygen, carbon, neon, and iron. The next star is Mu Hercules. Nearby quadruple star system, Mu Hercules is located in the constellation Hercules, 27.1 light year away from Earth. Its main star, which is Mu Hercules A, has a mass that is roughly 1.1 times the Sun and is starting to grow in size to become a giant. Next, 9 Pegasi. A supergiant star in the constellation Pegasus is called 9 Pegasi. It is a yellow supergiant that is 60 times larger and about 20,000 times brighter than the Sun.
Now, I will share about the properties of class G star. A G-type main sequence star, commonly known as a yellow dwarf or G star, is a main sequence star of spectral type G. A class G star has a mass of 1.1 solar masses and 1.1 solar radii. Class G has a temperature between about 5,000 to 6,000 Kelvin. Furthermore, the conventional color of G-class star is yellow, meanwhile the apparent color is yellowish white. The class G star has 1.1 luminosity and the hydrogen line is weak. It is made up 7.6% of main sequence stars. For the properties of typical G-type main sequence star, you can refer the table shown here. Next, I will share about the lifespan of class G star, which is Sun. Sun is one of the countless stars in our universe. It is a G-type main sequence star, often known as G2V or yellow dwarf. The Sun's life started around 4.6 billion years ago and will continue for another 4.5 to 5.5 billion years. A G-type main sequence star will fuse hydrogen for approximately 10 billion years until it is exhausted at the star center. When this occurs, the star expands too many times its previous size and becomes a red giant like Alpha Tauri. The red giant eventually sheds its outer layers of gas, which is become a planetary nebula, while the core rapidly cools and contracts into a compact, dense white dwarf.
As a conclusion, our galaxy Milky Way has billions of stars. Each star has their own importance. As for example, our sun can generate the weather pattern and give energy for the growing plants that will provide food and oxygen for the life on Earth.